What's up, my friends? Welcome to our second assignment. Hopefully you guys have finished taking notes and kind of understanding how computers work. They are devices at the very basic level, very basic. They are devices that interpret an input, like our keyboard. We tell it what to do, and then it processes that, and then it kicks it back out to us, right? So we're going to see like how all that works and how computer parts play their role. We're going to be using analogies with the human body because we're most familiar with that. So hopefully you guys can understand kind of how this goes. Now, this is something that I'm really passionate about. I really love computers. I actually built this one that I'm speaking on right now. And as you can tell by my gaming chair, and I got a nice headset right here, I'm a big-time gamer. So this is pretty much what I do in my free time. So let's go ahead and get started. The first thing that we want to cover is the most important part of a computer, I would say, and that is the CPU. Okay, the CPU is essentially the brain of the computer. This is a device that processes every command that we give it. So when you're looking at doing some basic things like writing a paper, okay, any CPU can handle that. It gets really challenging, and we need more brain power when we start handling multiple tasks at one time. So the CPU, the better it is, the more expensive it is, right? And the more tasks you can do on your computer. So if I want to play a game and I want to stream, I'm going to need a pretty good CPU. If I want to write a paper for school and watch Netflix, probably don't need that big of a CPU, okay? So basically how these work, they're measured in megahertz and gigahertz, okay? Megahertz and gigahertz, that is the speed. So what it means is how many instructions they can handle per second. So when you get gigahertz, we're talking billions of instructions per second, which is really what you want. Because even though you aren't personally inputting something, your computer is always managing instructions at all times, okay? Computers manage instructions and process instructions just to run. When I turn it on, that's an instruction. When it's sitting idle and it's asleep, that's an instruction. You get where I'm going with this? It doesn't always matter that I'm typing. It doesn't always matter that I'm clicking my mouse. What matters is that it is on, therefore it is processing instructions. So CPU, super crucial, super crucial, okay? Hopefully you guys got that. This is the brain. CPU, brain. Got it? Got it. The next one's called a heat sink. The heat sink is what covers and absorbs heat from the CPU. So you actually never see the CPU in a computer because it's always covered by a fan. Essentially, this is a fan, okay? CPUs get really hot, and they need to be cooled off. That's why airflow in a computer is super important. You don't want to buy a $500 CPU and then have it burn up and go to toast because you didn't provide it with enough airflow. So this whole function is to cool the CPU down so it functions well. This is mainly what you see over the CPU. Sometimes these are colored, like the one that I have, this fan right here, turns different colors. They're not always as rigid as this on the bottom. It's really, there's a lot of variables, okay? Next we have the hard drives. Now these are important. Hard drives are exactly like filing cabinets, okay? This is a great analogy. So they're secondary memory, and they're permanent storage, okay? So if I save anything to my hard drive, it stays there. So essentially what this does is it stores all the data, and it's like a mechanical arm. When I say that I want to open a file, I want to open Google Chrome. I need to go to my hard drive, and the machine hand comes down and says, Google Chrome. There it is. Let's open it. Done. Okay? That's how hard drives work. Pretty basic. You store all your stuff here. This helps you be able to access your information. It also helps with like boot up speeds. It's basically long-term memory. We're going to talk about two different types of memory. We're going to talk about random access memory. And we're going to talk about long-term memory. So random access is short-term and long-term memory. So get those in your mind. Hard disk, long-term. Hard disk, long-term. This is an SSD. This is called a solid-state drive. So essentially what this is it's just another hard drive that we just went over. And it is a it operates as a flash drive. So a lot of people wonder what the benefit of an SSD is, and let me tell you. When I am running a bunch of commands off of one hard drive, I can overload that hard drive pretty fast, right? If I'm like, open this program, open that program, keep my movie on, download music in the background, all that stuff. That can overload a hard drive really fast. So what a solid state drive does is you can navigate through your computer to save information on a different place, so you can kind of spread out where things are saved. The biggest benefit to this is speed. Okay, the biggest benefit to this is speed. So what a lot of people do is they have their operating system, which is typically Windows 10 maybe. If you're on Apple, you're on like Mac OS. I can't remember what the name is right now, but you're on Mac OS, okay? And so what they'll do is they'll have their hard drive right here, and this will be their whole operating system. This will be their Windows 10. And then on their solid state drive, this will be like all their games, all their photos, all of that stuff. The reason we do that is because we only want our hard drive to be handling one task at a time, and that's the function of our computer, of our operating system. We want everything else to be on the solid state drive to increase our speed so we never compete with any of the energy and instruction that's given to our hard drive. Okay? So that's why we have two. Solid state drive, store all the non-important stuff is kind of how I do it. And then on my hard drive, that's where I put my actual operating system. So this is a ROM, read-only memory. This is memory that can't be modified. So it holds programs for booting up the computer. Basically, your operating system. Here's RAM, random access memory. This is short-term memory. What this does is it helps your computer store little instructions or little commands so it operates. So when a computer does anything, it needs a place to store what you just told it to do, and that's what RAM is. So the computer says, okay, you want me to open Google Chrome? Let me go store that in my random access, and then I'll open it up, and then it's gone. Okay, it's not permanent. It doesn't stay there. It doesn't stay there. Okay. Video and graphics cards, this is what is important for us to get great graphics, usually when we're gaming, pretty much. It helps our monitors actually reach their potential. So a GPU is really critical in providing a great output and the clarity of the picture. So this is basically the difference between something that's 1080p and 4K. If you want something 4K, you're going to need a beefier GPU, as well as a better monitor. If you want something just in 1080p, you wouldn't necessarily need a GPU that's wild. GPUs are what we use to process and interpret any kind of graphic, really. So if you want your pictures to be more clear as far as like games go, you're going to need a better GPU. Okay? Anything like if you just want to do Photoshop, you don't necessarily need a super big GPU. It does help, but it's not super necessary. We just want it for enhanced performance. A lot of motherboards have these built, but I will say that the integrated ones are not super awesome. You're going to be able to do really basic things, but besides the basics of a computer, like if you were trying to play Call of Duty, you would need to buy a GPU. Sound cards, I don't really know too many people that use these. Most people just buy another set of speakers and plug them in on the back. But every motherboard is built in with a sound card, so you can hear whatever you want. The sound quality is not super awesome, but if you upgrade this and use some nicer speakers, your sound quality can be great. Next up, we have the motherboard. This is the main circuit board. This is the big thing that you see inside of the computer. Let me kind of tell you where things go. So right here is where the CPU goes. Okay, this is where our RAM goes. In the back, this is what you see when you're plugging things in. So you'd plug in like an HDMI cord back there. You could plug in speakers. You could plug in a USB. You could plug in a lot of things back there, really. This slot is typically for the GPU. It'll stick up and then poke out the back so you can connect. And yeah, there's so many different areas. So those are the basics, okay? All these little plugs are so the different things that you plug in actually get power. So when we think about the circuit board, it's really the central nervous system. Okay, so here's our brain. The brain's getting all this information, and then it disperses out what it needs to accomplish across the motherboard. It goes to different parts, right? If it says I need to be playing this movie, it'll go to its memory, it'll go to the GPU, and all these parts will work together in order to create one functioning machine. And those are the basics of computers. I forgot a power supply. How can I forget a power supply? This is exactly how it sounds. This is what turns your computer on. Okay? And that's all it does. So the important part of about a power supply is that each power supply provides a different wattage. What this does is it converts electricity from your wall into power for your computer. It sends power through all these cables. So when we look at, you can see all these cables back here. They're like orange and yellow and whatnot. They all plug in right here and right here. Those are the main two slots for them. They even go, there's some that will come over here into this black section here. But yeah, power supply is super important. If you don't have a power supply, you don't have a computer. So the wattage is really important. Like I talked about earlier, you want to make sure that you provide enough wattage for what your parts demand. And a really good way to see this is on a website called PC Part Picker. What it does is it will take, it's basically a build list. You can select what you want. You guys may have used it in assignment 1. You can select what you want. It'll give you the prices across the internet. But the cool thing it does is it also gives you the estimated wattage that that particular part will demand. And so really high-end computers are probably over 450 watts. So you'd want to make sure you buy a power supply that meets that. But you don't need to, it doesn't need to be overkill, right? Like you don't need to buy 450 watts if your computer only demands 200. Not a big deal. Cool. I will post this video as an embedded video so you can give it a watch. But that's pretty much the internal components of a computer. I hope you thought this was useful. I hope you had a great time. Key parts to remember. Number 1, CPU is the brain. Number 2, motherboard is the central nervous system. And then part number 3 is that there are 2 different types of memory. There's long-term and short-term memory, okay? Short-term memory is random access memory, called RAM. Those are like the big sticks that you see, okay? They're like this long. And you should have seen them when you were building the computer, okay? They're like this long. Usually Corsair is a popular brand. And then you have hard drives and SSDs, which are long-term, okay? Things get deleted from there only if you delete them, but they stay there permanently, whereas random access is just for a few seconds, if that. Until next time, my friends.